Welcome to the June 2023 Edexcel GCSE paper 3H. Walk through question number 1. Multiply the powers m to the 6, add the powers x to the 13, and then 4p cubed plus 12p squared when you expand those out. Question number 2. To find 68% of the people, 800 times 0.68 is 544, and then 544 times 2 times the 10.6 grams comes out as 11,533 grams. Well, if the number of people drinking coffee is greater, then he will need more coffee. Question number 3. Question asks us to give a reason for each stage of our working. So angle CFG is 55 degrees because angles on a straight line will sum to 180 degrees. Angle ACD is 55, that's corresponding angles. Angle ADC is 70 degrees because angles on a straight line will sum to 180. And angle CAD is going to be 55 when I subtract the other two angles from 180. I probably should have put the angles in a triangle add to 180, but I didn't. Anyway, we have two 55-degree angles, and so therefore our triangle is isosceles. Question number 4, if we take the 14 hours times by 5, it tells us how much one pump would do it in. Divide that by 4. For 4 pumps, it's 17.5 hours. For 5a, looking at the prime factors in both, we've got a 3 squared in both and a 7 in both. So 3 squared times 7 is 63. Then for the lowest common multiple, we've got a 2 squared, 3 to the power of 4, and 7 squared. That's 15,876. For question number 6, if we take the 67,205,600, divide that by 11.9, and then divide that by 60 to turn it into minutes, 60 again into hours, 24 into days, we get 65.3. So that's 65 days to the nearest day. The turning point's at 1 minus 3. Then either point where the line crosses the x-axis, you could have had minus 0.8, you could have had 2.8. Either of those two would be fine. Actually, anything between minus 0.8 and minus 0.6 if you went for that one, or anything between 2.6 and 2.8 if you went for the other one, is a perfectly acceptable answer. All right, question number 8. We're just going to multiply 9 and 72 here, multiply the density by the volume to get the mass, which is 648 grams. Question 9. So 0.7 for the number of people who say yes, 0.8 for those who say yes, want it with a large screen, multiply the two together, 0.56, that's 56%. Question number 10. Sine of 41 will be the opposite over the hypotenuse, so sine of 41 will be AC over 6.8. Multiply both sides by 6.8, we can work out that AC is 6.8 times sine of 41, which is 4.46, etc., etc., etc. Then trig with the left-hand triangle, tan of 55 will be the opposite over the adjacent. That's going to be this AC we've just calculated divided by DC. Multiply both sides by DC, divide both sides by tan 55. You can do that in one go if you like. We can calculate DC by doing 4.46 divided by tan 55. Try and use the answer button on your calculator to avoid rounding partway through a question. And if you've done that correctly, you will get 3.1 to the nearest 1 dp. Okay, for the box plot, so lowest value at 169, and then 174, 177, 180, and 186, and join them all up to get a little box plot like that. Then we need to compare two things. We need to compare the median, and we need to compare a range. I've chosen the interquartile range. For the median, well, the median of the adults is higher, is greater than the median of the teenagers. So that's my first comparison. My second comparison, you could do overall range, but I've chosen interquartile range. Interquartile range, if you calculate them, they're actually the same. So the interquartile range of the adults is the same as the interquartile range of the teenagers. So the spread of heights of that middle chunk is exactly the same. Okay, question number 12. So we're expanding out a triple set of brackets. You pick any two of them and expand them first, then multiply it by the third one. I've picked the first two to expand, so x squared plus 2x minus 3. And then we're going to multiply that by x minus 5. And then multiply everything in the first bracket by everything in the second bracket. There's going to be an x cubed, a 2x squared, a minus 5x squared, a minus 3x, a minus 10x, and a plus 15. Then collect the like terms together. So 2x squared minus 5x squared is minus 3x squared. Minus 3x minus 10x is minus 13x. And the x cubed and plus 15 are still there. Right, for 13, consecutive terms of the triangular numbers. So the first one, n plus 1 over 2, that's my first number. Now if I increase n by 1, I can replace n with n plus 1, and I can replace the n in the bracket with n plus 1 as well. We get n plus 1 lots of n plus 1 plus 1 all over 2. All I've done is replace n with n plus 1 for the next term. Expanding the first one out, we get n squared plus n over 2. And I've simplified the right-hand bracket on the second fraction. So rather than n plus 1, it's n plus 2. Can now expand that out, n squared plus 3n plus 2. We have a common denominator of 2, so I can add the numerator straight away. 2n squared plus 6n plus 2, that's all over 2. As they're all even, that will cancel down quite nicely to n squared plus 2n plus 1, which is what you get when you expand n plus 1 squared. So n plus 1 squared is, of course, a square number, and so we're done. Question number 14. So we're going to use the cosine rule to find OB. I am going to jump straight in with b squared plus c squared minus 2bc cos a, and then square root it all, and that will find OB. That's equal to 5.34, so that's the radius of the sector of the circle that we're looking at. Then to find the area of that sector, so theta 360ths of pi r squared, in this case 80 360ths times pi times my 5.34 all squared, try not to round it, and that comes out as 19.9 centimeters squared. 15a, that's the difference of two squares, so a plus b, a minus b. And then 2 to the power 40 minus 1, that is also the difference of two squares, so that's going to be 2 to the 20 plus 1 times 2 to the 20 minus 1. Now we know that 2 to the power of 20 is going to be even, because it's a multiple of 2. And therefore 2 to the power of 20 plus 1 was one more than an even number, so it's going to be an odd number. And 2 to the 20 minus 1 is going to be the previous odd number, so we have two consecutive odd numbers here, and it's the product of them because they're multiplied together. Question 16. So our centre of enlargement's at -2, -2. I'm going to draw straight lines from the vertices going through that point, and then work out that the new points are going to end up twice the distance from the centre of enlargement along the other one, and we get an inverted shape which we can join dot to dot like that, and there we go. We've carried out the enlargement, scale factor -2. Question 17. Do your best effort at drawing a tangent at that point when x is 2.5. We've got ourselves a little triangle here. We can estimate the gradient by doing the change in y over change in x. So 46 over 2.7. That comes out as 17. So my guess is 17. Anything between 16.5 and 19.5 is acceptable for this question. And that change in distance is called a velocity. Question 18. So we're looking at scale factors to begin with. I'm looking at scale factors of the two cones, including the cone that's been cut off the top. The two cones will be similar. So the scale factor of lengths, just looking at the slant height of both of the cones, is going to be 6 to 10, or simplifies to 3 to 5. Therefore, if we compare the radii, the radius of the smaller circle on top over 3 is going to be the same as 3 over 5. And so that shorter radius is going to be 9/5. Then to find the total surface area, we've got the area of the two circles, pi r squared, so pi times 3 squared, and pi times 9 over 5 squared, plus, and then it's the curved surface area, so the curved surface area of the large cone without the top chopped off, which is pi times 3 times 10, and then subtract the chopped off bit, that's pi times 6 times 9 over 5, plug that into your calculator, and you'll get 98.8 to 3 significant figures. Question number 19, it's passing through the origin. It shouldn't, it should pass through the point 0, 1. 3 to the power of 0 is 1, not 0. Question number 20. So recurring decimal to fraction, so x is 0.1 and then 2, 3 recurring. Times that by 10 to bring the recurring part up to the decimal point. Times that by both sides by 100, because we've got 2 recurring numbers, so 1000x equals 123.23 recurring, and subtract 10x from 1000x, give us 990x, and 123.23 recurring, subtract 1.23 recurring is 122. Divide both sides by 990, 122 over 990 simplifies to 61 over 495. Question 21. We'll give ourselves a common denominator. I'm going to multiply the top and bottom of the first fraction by 2 minus 2x and the top and bottom of the second fraction by x plus 4. I'm going to expand those and add them all in one go. And that's going to be equal to 1. Then multiply both sides by x plus 4 times 2 minus 2x. I'm going to expand the brackets as well and collect the like terms on the numerator to get x plus 14. Then we've got a quadratic equation, so I'm going to bring everything onto the left-hand side. 2x squared plus 7x plus 6 equals 0, and that factorizes to 2x plus 3 times x plus 2 equals 0. So x equals minus 3 over 2, or negative 2. Question 22. So we know that the vector is parallel to 13, 6. So it's going to be a scalar multiple of 13, 6. So the x component will be 2a plus 8b. That's going to be a scalar multiple of 13. The y component will be 6a plus 2b. That's going to be a scalar multiple of 6. If I divide everything in the second equation by 6, we get a plus a third b equals k. I can substitute that into the first equation. So 2a plus 8b equals 13, lots of a plus a third b. I expand out the right-hand side, 2a plus 8b is equal to 13a plus 13 thirds of b. Then I'm going to bring the b's onto the left. So 8 is the same as 24 over 3. So 24 over 3 subtract 13 over 3 is 11 over 3b. Subtract 2a from both sides. That's going to be equal to 11a. Multiply both sides by 3, divide both sides by 11, we get b equals 3a. Question 23, I think a little sketch here is useful. My circle is not centered particularly well around the origin, please forgive me for that. We've got our point negative 3, 4 on the circle. And we're working out where that tangent to the circle crosses the x-axis. Alex says it crosses the x-axis at negative 8, 0. That radii I've drawn there to meet the tangent, I'm going to call that L1, and the tangent itself I'm going to call L2. You don't have to do that, it just makes the working clear. Right, the gradient of L1, well, it goes from the origin to negative 3, 4, so it's got a gradient of minus 4 over 3. The gradient of the tangent is the negative reciprocal of that radius, so 3/4. Now we know that this tangent passes through the point negative 3, 4, so we can work out the equation of the line L2. Now we know its gradient. It's going to be plugging y to be 4 and x to be negative 3 into y equals mx plus c. We get 4 equals 3/4 of negative 3 plus c. And c is therefore 25 over 4. So the equation of L2 is y equals 3/4 x plus 25 over 4. Now let's find out where that crosses the x-axis. I'm going to set y to be 0 and solve the equation. So 0 equals 3/4 x plus 25 over 4. Bring the 25 over 4 onto the left-hand side. Times both sides by 4. Divide both sides by 3. The x-coordinate is minus 25 over 3, which is negative 8 1/3, which is not quite negative 8. So it's close, but it's not close enough. Negative 8 1/3 is not equal to negative 8. Therefore, Alex, I'm afraid, is wrong. Hard luck, Alex. Okay, question 24. Well, the ratio of pink counters to the total number of counters is 1 to 3. So if we call x the number of pink counters, the total number of counters is going to be 3x. So I can use that as my denominator. Probability of picking a pink one is going to be, well, there's x pink ones out of the 3x. You could simplify that to a third, but because we're doing repeated picks here, I'm going to leave it as x over 3x. Probability of picking a blue counter on the first pick, well, it's going to be 5 out of 3x. And the probability of picking a green counter, well, it's going to be whatever's left. So if we've got 3x counters in the bag, we take out the 5 blue ones and the x pink ones. The remainder are green, so 3x minus 5 minus x green counters out of the 3x. I'm just going to tidy that up quickly. 2x minus 5 over 3x. Then we want the probability of picking 2 of the same, so that's pink pink or blue blue or green green. Well, for pink pink, if the first pink pick is x out of 3x, the second one, I'm going to decrease the numerator and the denominator by 1 because we've taken one pink one out. So it's going to be x minus 1 over 3x minus 1. For blue, I do exactly the same, 5 over 3x, and then subtract the top and bottom by 1, so 4 over 3x minus 1. And similarly for green, the first pick, 2x minus 5 over 3x, and then 2x minus 6 over 3x minus 1. And the sum of those probabilities, because we don't mind which colour it is that is the same. We have a common denominator already straight away, so we can expand the numerators, multiply numerators together. There is a mistake there. It says minus 27x. That should read minus 22x in the numerator. Fortunately, I do correct it on the next line, and I have spotted it, so it doesn't count. Please don't write in, because it only counts if I don't spot it. Anyway, collecting the like terms, we end up with 5x squared minus 23x plus 50 over 9x squared minus 3x. Well done.